Alright everybody, here goes a video on how to prove triangles congruent, and this is going to be done with the two-column proof method. Now a little heads up, this video might be a little lengthy because proofs are very involving and they're going to require a lot of work, and I will just throw a blanket statement out there that sometimes teachers expect different things in your proofs, and there are different ways to do proofs that could all be correct. So as I go through this video, I just want to let you know that this is the method I prefer, but other teachers might do something different, so make sure you are ready to adapt. So the way I always look at proofs is you need to have at least 3 congruent statements to prove triangles congruent by all of our different methods. Side, 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 angle, side, and all of that fun stuff. So the first example here is the easiest type of proof I can give you because all of the statements are already given. So there's no thinking outside the box that needs to be done except for which method are you going to use. So let's just start with the first given. Some teachers say list all the givens in the first step. I like to separate all of mine for a reason you'll see in a little bit. So the first given is AB is congruent to XY. And the reason is because it was given. After you write the statement, you must mark the picture. It will be very beneficial to you. So AB is congruent to XY. It's marked. It's good to go. Once you have a congruent statement, it's gone. We don't need that guy anymore. Move on to the next given. Given number 2, BC is congruent to YZ. The reason, it was also given. Now mark your picture. BC is congruent to YZ. Done with that guy. Last given. Angle B is congruent to angle Y. Third reason, still given. So go mark angle B congruent to angle Y. Now you can see we have 3 congruence steps and they are all marked in the diagram. So last thing you need to do is prove triangle ABC congruent to triangle XYZ. And we have enough information. This is a side, this is an angle, this is a side. So we're going to use the side, angle, side pattern. The angle is in between the 2 sides. And that's how you prove triangles congruent. Okay? Now, as I mentioned, that's the easiest possible one where everything was given to you. Now, I'm only giving you one given, and it doesn't say that anything is congruent. So you're going to have to use what's given here in the given statement and what's in the diagram to find all of your congruent parts that are needed. So let's begin. First thing you do is list your givens. Well, there's only one given this time, and that's C bisects AE and BD. And the reason is that it's given. So now we need to go find some congruent pieces out of that. So the first thing we can do is think about what a bisector is. So when C bisects a segment, that technically means C is a midpoint, or C is a bisector, which means it cuts something in half. So we can see that if AE is bisected, we know that AC is congruent to CE. And we also know that BC is congruent to CD because C also bisects BD. So then what would you use for your reason? Well, this is where you can give an if-then statement, or you can actually just describe what's happening. But basically what you need to say is bisectors cut a segment into two congruent segments. And there's, of course, other ways of writing that, and that's your exact same reasoning for number 3 as well. So some teachers will make you write it twice, some of you will make you write it once for both of those reasons, but since the one given gives you two of those exact same statements, for me it's okay to write that once. Okay, and now you're done with the given, but you still have to go mark your pieces. So BC is congruent to CD. And the first one we had was AC is congruent to CE. So we only have two congruent statements so far, and we're out of givens. Well, this is where you start looking at the actual diagram. Sometimes there's information hidden in a diagram that does not need to be laid out in a given statement. And this is one of those examples, because back in the day, you learned that angle ACB is congruent to angle DCE. And the reason why is vertical angles are congruent. So we can mark these angles vertical from the very beginning. Now here's another one of those strategies where, you know, if you want for yourself, you can list all of the givens directly from the picture first, and then go with your givens. So just another thought. You can work with these however way you want, as long as you get the correct answer. So 5, we now have enough information. So once you have 3 pieces, again, we have a side, an angle, a side. This is side, angle, side again. So we can say the triangle ABC is congruent to triangle EDC by side, angle, side. All right, so there you go. There's 2 examples of proofs done for you. There is one more. If you feel you understand, you got the flow, go ahead and try some practice problems on your own. But if you would like one additional problem to try by yourself, here it is. Now, I will say this one has a different given, a different diagram, because there's no way I can do every possible example in one of these videos. It would take hours. There are so many different types of proofs and styles of proofs and different givens that we can't cover it all. But if you have the layout and if you have a general guideline of how to do proofs, there are many ways to do them correctly. You just have to pick a way that works best for you and follow it. So go ahead and pause this video if you would like. Try this one. I will give you a hint. This one should be approximately 6 steps. You might get it in 5, but there was one step that I predict you might miss. So go ahead and pause it and give it a try. Let's see how you do. So the first thing you probably did is said that MT was perpendicular to AH. And that's given. Now, if you do things my way, you're not going to go list the next given yet. My suggestion is that you don't stop with the first given until you have found something is congruent. So to follow along with this, what does perpendicular do? Well, if MT is perpendicular to AH, then that means angle MTA and angle MTH are right angles. And the reason why is perpendicular segments create right angles. They always do. Perpendicular will always create right angles. They do not create congruent angles necessarily. They create right angles. But then from there, you can say that angle MTA is congruent to angle MTH. And the reason we know that is because all right angles are congruent. Now, that's a very important thing because All acute angles are congruent, all obtuse angles are not congruent, but every right angle in this world will be congruent. They're always going to be 90 degrees. So since perpendicular lines create right angles, that means they are creating congruent angles in a way, but you just need to be careful how you state that. Now we can go mark our picture with our two congruent angles. Now we can move on to the next given. Step 4 would have been MA is congruent to MH. Now, if you have this as step 2 or even step 1, that's still fine as long as you're doing things in a correct order. They don't have to be the same order. You could just have easily put that as step number 1 and then gone with the second given. Whatever works for you. So, of course, this is a given statement. Go mark the picture. MA is congruent to MH. Done with that guy. Again, we only have 2 markings. So this is where you need to think outside the box, or shall we say outside the triangle again. If you're out of givens and you don't have 3 congruent statements, you need to use the diagram. And we can see that MT is congruent to MT. Now this is by what's known as the reflexive property. Okay, but basically what this means is there's a shared side. So we're trying to prove that triangle AMT is congruent to triangle HMT. Well, if we were to take some scissors and cut that diagram in half, we would have 2 right triangles that are split, and this one is named MAT and this one is named MHT. So as you can see, MT is in both of them. That's why it's known as the reflexive property, also known as a shared side, because that MT is in both of the triangles that we are trying to prove congruent. Now you can see we have enough room. So we have an angle, a side, and a side. And you've already learned that you cannot prove triangles congruent by angle, side, side, unless we have a right angle. Because those are not angle, side, side anymore. What that is this is a leg, and this is a hypotenuse. So we would finish with triangle AMT is congruent to triangle HMT. And your reason would be HL or RHL, whatever your teacher tells you should write. All right, so that's it for this video on 2-column proofs. This is Longo and I'm out. See you, bye.